thank you for the lunch.
Thank you.
I was remarking to my friends that I don't understand why this kind of organization isn't basically 100% Diet Coke, but one of the very, now I realize I'm doing ads for Diet Coke for people who see this on YouTube in the future. So for those of you from the future, Coke is it. But one of the things that annoys me the most about Butler Library, actually, if I could change one thing about Butler Library, it would probably be more entrances to the stacks. If I could change two things about Butler Library, it would be more entrances to the stacks and to stock Diet Coke in the coffee shop. So they have Pepsi and Diet Pepsi, but no, it's just, I mean, I went and spent $3.50 on a bottle of Diet Pepsi. I don't know what's going on here. Anyway, so those are my ads. I've written to my colleagues in the libraries to come pick up lunches, so there may be people you don't know coming in and absconding with the food.
Do you want me just to go to circulation and pick it up?
I mean, if you want to take up a box, go ahead.
Just bring it to circulation. I already brought food to ship it, so.
Okay. Yeah, so if anybody shows up, we can just say, yeah, all the food's gone, sorry. Anyway, thanks, Dan. That's probably more productive than what I suggested. Again, here is the link in case you lost it. Columbia-data.club/WIS-2023. And that will take you again to this GitHub page. Whoops. Boom. And then from here we have our third notebook. And just click on Open in Colab, just like we've done so far. And everything should be fine. Now, this part of the workshop is special. Initially, when I do this, so when I typically do these text analysis workshops, what follows is that we use specifically some kind of library that is specific for text analysis. There are many of them, and if you see, you'll see that I don't know why these keep opening. Down at the bottom, I have this little bit of text written up about what is text analysis, and then below that, I gave some examples of NLP libraries. NLP stands for natural language processing. We are going to do none of that because we are going to ask a very simple question, which is how many women get published in JPE? And that is a very simple question to ask. And answering it is not that tricky, but answering it sets up and lets us model many complicated things. So I don't even know if I'll get through everything in an hour, hopefully, but it may take a little bit longer than that. But I have this what is text analysis here too. The long and short of it is there are basically 2-3 libraries that you need to know about if you want to do text analysis in Python. NLTK, Spacy, and Gensim. NLTK is the old one that does everything. Spacy is the new one that's fast and makes a lot of decisions for you. So it lets you get up and running quickly. If I can only teach one, I would teach Spacy. And Gensim does topic modeling, which is a way of organizing documents. Because when you do text analysis, you have a bunch of different things. You can be looking at sentences, you can be looking at documents, and you can be organizing textual information in many different ways. So one of those is called topic modeling. Okay, but we are going to do none of that because, and that's actually ultimately why we didn't even need the full text of JPE, because just dealing with that first column that we had, creator, that had the lists of how many authors, of all the authors, just working with that is already like a jillion research questions, like just from that. I mean, that then you want to look at the full data to understand better. But just from working with that one column, which is basically plus minus all we're going to do, will still be productive, I think, and fascinating. So, so I said here, Vanshika suggested that if we can intuit anything regarding female authors. So, so what this then becomes is an opportunity to sort of do some kind of like, did I start recording? Yes, okay. To do something like figuring out how do you solve this problem? If you want to know something about women authors in JPE, like you have to be able to break this thing. You can't just say, Alexa, tell me something interesting about women authors in JPE. You have to break this down into a series of steps that you are going to try and solve somehow. And you break each step down into a smaller step, and then into a smaller step, into a smaller step, until you recognize this as, oh, this is one line of code to do this. So the plan is, we load in the data. Obviously, we need to load in the JPE data, and we're going to load in those files that you saved at the end of the last module. That's why I made sure that you all got to that, so that you could upload those files, because now you have something to download. So I don't have to email you all anything, because you all have that file in your Google Drive. Then we need to turn our list, the data set that we have is a list of articles. It's a spreadsheet where every row is an article with different parameters, right? Like the page count, or the word count, the authors, etc. We need to turn what is a list of articles into a list of authors. These are two fundamentally different things. I mean, obviously, but it's a little subtle, because we can't just, if it were the case that every article had just one author, then maybe it's the same thing, but it isn't. The number of authors is different from the number of articles. Then we have to ascertain the gender of each author. You can probably guess that this is very hard, and we don't have a good answer for it. We have a crappy answer, and that's the one we're going to use. So we'll get to that in a second. Then, once we determine the gender of every author, we go back to the list of articles, and then we say, like if there are 4 authors, we say, okay, this is 3 men and 1 woman. Or 2 men and 2 women, or 4 women. It's not going to be the case that it's 4 women. But we do something like that, and then we can compare the genders of the authors back to the articles themselves. Then once we have done all that, we have a new way of looking at that list of articles. And then I say here, we can group our data set of articles. We can use the group by thing that I sped through so quickly at the end of the last module. We can group our data set of articles by whatever criteria we like to see the relationship between the number, the percentage of women authors, and whatever criteria we are tracking. So that's the plan. So you can see already that we asked a relatively straightforward question: what can we know about women authors in JPE? And all of a sudden, it's 5 steps to take care of it. And these 5 steps are big steps with many, many little steps. So let's start with loading in the data. So this is very similar to what we did last time. So you can see it starts with an import statement. Import pandas as PD. Then I created this thing called file path. And if you remember, last time the file path was like /content/da-da-da that you got from the kebab menu. So this is just the same thing except in reverse. Instead of copying the file path from the kebab menu, I already know what the file path is. So it's going to be drive/my/drive/jpt full no authors parquet. But for this to work, I haven't pressed play yet. For this to work, you need to mount your Google Drive. So on a Mac, it's as simple as that. On a PC, I learned today, the PC will inject a little bit of code that you have to press play first. It'll say something like import Google something something, mount drive something something. But the point is you should have a folder called drive show up here. Let me zoom in a little bit. You should have a folder called drive that shows up here. And then once you have this folder here, you should be able to press play, run anyway, and this should work. It'll take a minute, but it should work. So I didn't describe what Parquet is. Parquet is a file format just like JSON, just like CSV, just like Excel. Parquet is very good for big data because it does a bunch of things, but most importantly is it's a binary format instead of a text format, so it takes up less space. So the JSON-L file that we downloaded was 70 megabytes or so because it was a text-based format. That same information saved as a Parquet file is 20 megabytes because binary encoding data as binary typically takes up less space. So one more time, to get this cell to work, before it'll work, you have to click on this folder with the little triangle icon to mount the drive. And then it will, on Windows, it will inject a cell that you have to play, and there'll be a little blue square that says, like, you have to run this cell before things work. You press play on that, then the drive folder will show up here, and then you press play on this cell that I already created. So far, so good?
How do we get drive on there again?
You click on this, and then again, when you click on this, if you're on Windows, it will create a new little cell here that says like import Google APIs or something, and then it'll say like mount drive, and then you have to play that cell, and then the drive folder will show up.
When I do that, nothing happens.
If you are you on a Mac or a PC? I can't tell. You don't have that injection doesn't happen on the Mac.
It just doesn't. I don't have drive. Wait, which one?
If you click on refresh, the little refresh icon, that should work. That should refresh it, and it should show up. Are you logged in to? You also have to be logged in. Yes. So okay. Yeah. Let me run around and see what the problem is. You don't have to worry about it, basically. It won't be.
But it doesn't have Google
It's, but it worked, yeah. If it works, then that's fine.
So where do I
Okay, click on this to mount the drive, and then that'll take a second. Okay, so it says run this cell, so hit dismiss, and press play there.
Oh, sorry.
And then, okay.
No.
Well, but with whichever account you were using, you're all set. All right, who's next? Yes, so then if you get this little thing, you do dismiss, you have to play this. Anyway,
He was like a great job.
log in with whatever Google account you used to save the file last time. It's You're all set? You're all set. You're having trouble. Okay, this is the old, did you not ever save the file?
way down.
I think we do.
Yeah.
I think we do.
That's cute.
But in my case, it's
Oh, okay. So what is that?
so what is this? Yeah, in Argentina, like women have 3 months.
I like that. That's interesting that you're kind of just.
Okay.
Sorry,
yes.
I didn't get it. I'm so sorry. I didn't know that you asked. But
Okay, press play.
It seems to never because I get happy idea.
just flesh it out. Yeah, just.
Press play again. No, just press play.
Yeah.
Okay, now we'll just say.
Stakeholders and
Okay, so you maybe didn't save the file at the end of the last. Yeah. So actually, okay. So some of you, I thought all of you had saved the previous file, but some of you didn't. So I'm going to email the file to you all. We're back to doing that. How come this isn't?
It's saved as GPT, not GPE, I think.
Oh, I wrote JPT. Okay. That is correct. Okay, so now for those of you who haven't been able or are having trouble connecting because you didn't save the file and I made mistakes, I called it JPT. You now got it, so now you can upload the file the way that you uploaded it last time. I can't do the little trick where I show you the content. I mean, I can actually. Why not? Let's switch back to the notebook. Let's go to Drive, My Drive. There's all this stuff. JPJJJJJJ. Okay, so I can, do this silly thing where I show the.
Wait, let me record this.
I don't know that it actually worked. Oh, now it's downloading. Okay, now it downloaded. All right, you ready for the matrix? Oops, not open. Cat GPT. It might not work because it's a binary file anyway, or it's download. I don't know what's going on here. And I killed my computer. Okay. We'll come back to that, and then you can. But anyway, the point is if you downloaded the file from your email, then you do the same thing. You upload it by clicking here, and then you drag it in. So I'll model this right now. You click on the folder icon over here to open this up. Then you click on Upload. Then you navigate to wherever it is that you saved the file. It's called JPT, not JPE. So it's JPT, full, no, zero authors, Parquet. You do Open. It says you have to save these files. Then there's this little blue spinny that goes that shows that it's uploading. and then it will show up here, and then you have to change the file path so it's just this. And then you'll be fine. But the point is if everything works correctly, when you do df head, you should see this. Okay? So I'm going to do this once more. No. JPT full no 0. Oh, it's not done uploading. There you go. So it worked for me with the file that I emailed. Okay. So are you all at this position where you see this the spreadsheet looking thing again?
Yes.
Raise your hand if you do not see the spreadsheet. Okay. Or you'll take care of it then? Thanks.
I have a question.
Yes.
The reason that the creator name is showing first is because of what we did in the last module.
No, the creator column is always the first column. That's JSTOR did that.
Okay, so we're still going to pivot it. We haven't done that yet.
No, yeah, that's the first step. Yeah.
I have another question.
Yes.
How do you get those cats to walk on your hand?
I don't remember. You have to Google it. Just Google collab cats. Yeah. And there's a corgi also wearing a Santa hat.
Yeah, I saw it.
Okay, now who doesn't have the spreadsheet? All right. So I'll start moving forward. So the next step. Are you all set? Okay. The next step is to turn the list of articles into a list of authors. So this is a big step that I break up into little steps. So what we do is we create an empty master list of authors, right? Just an empty list of authors. Then we are going to iterate over df. df, to remind you, is the data frame that is all of the articles. So we are going to go row by row over the data frame. That's here too. Then for every article, we pull out the list of authors. Remember, every article has a creator column that has a list inside of it that is the list of authors. So for every article, we pull out the list of authors and then iterate over the list of authors. And then for every author, so we are 2 for loops in. For every author, we add them to the master list of authors. So now the master list has all of the authors of all 11,000 articles. The problem is there are duplicates because some people publish more than one article. So then we turn that master author list into a set. A set is like a list except it guarantees uniqueness. So a regular list, like I can make a list that's bracket 1, 1, 1, 1, 1, like just a 1 over and over again. I cannot create a set that is just 1 a bunch of times. So we turn the master author list into a set, so we get the unique authors. We get a list of the unique authors, and like I say here, and now we have a list of all the unique authors. So it's a lot, but this is actually the easier part, and I pressed play by accident. So the first thing we do here, let me zoom back in, is we create the empty list. Master author list is equals brackets. That's an empty list. It has a length of 0. Then I create a function called add creators to master list. So and it takes as its parameter creator list. So creator list is a list of creators. So because it's a list, that means we can iterate it. So I pass this list into the function called add creators to master list. And then inside the function, I now have this thing called creator list, and I can do a for loop on it. So for creator in creator list. And then what I do is I append the value of the creator to the master list, which is empty. And because the master list is defined outside of the function, there's just one copy of it, and it just keeps getting these authors added to it over and over and over again. All this is to say that if I do df creator apply add creators to master list, oops, I have to, no, that's fine. I end up with a master author list that's 20,000 characters long, 20,000 authors long, which means not that there have been 20,000 unique authors in JPE, but that there have been 20,000 authors, period. So we can see who are the most common duplicates. So what I'm doing here is I'm doing the value counts, which gives you all of the unique values and says how many times they appear in the list. And then I said, show me just the top 15. So I don't know. Milton Friedman I mentioned before, like, you know, you tell me if this looks like JPE's heaviest hitters, but these are the people who have had the most authors in JPE since between 1900 and 2017.
That's like one woman, if I have to guess.
It's going to get worse. It's going to get much worse. Don't worry, it's going to get much worse. So now let's get rid of the duplicates. So I said again that we make a set to create unique values, and then we take the list of all of the authors, then we turn it into a set, which gives us only the unique values, and then we turn that set back into a list. That's just to be funny. And we see that there are 10,000 unique authors. So what this means is that on average, an author has 2 articles. And a JPE author, on average, has 2 articles in JPE. No big deal. Easy stuff. So now things get very tricky, because how do we ascertain the gender of each author? Fortunately or not, there is no, when you submit an article, there isn't a little form where you get to tick, you know, like what your pronouns are and what your gender is. That would actually be kind of helpful, because sometimes when you're writing about someone, you don't know what pronouns they use, and then you end up in awkward situations. You know, I remember in undergrad I misgendered a professor at Columbia, but these things happen. So the question of how you determine someone's gender from their name is a very difficult question. It's just a very, like, if you spend more than 3 seconds thinking about it, you will realize how difficult a question this is, because you can't even do this in real life. Why should a computer be able to do it better than you? There is a library that lets us guess people's gender based on their names. It's called Gender Guesser. It hasn't been updated in 5 years, I think, or something. Yes, Dan.
Based on one of the Sex Machine, by the way.
What's that?
The original library was Sex Machine.
Okay, great.
It's just important information.
Yes, so there are online services that claim to do this. They all cost money. I thought about using one, but I didn't. So we're going to use the Gender Guesser library in Python. If I open up a new tab to look at the Gender Guesser, we can see that it is, you know, like I said, it's still in massive beta. It was released in 2016. I think the latest version is from 2017 or 2016. You can tell how old this is because it's using old Python syntax it's using the Unicode tag. This is for Python 2.7. You don't need to use this U anymore. You can just feed Unicode straight into Python for the most part. And it gives you the gender. So anyway, it's an old piece of software, but it gets us some of the way to where we want to get. So now I'm going to open this up. Gender Guesser is not installed. So you run this little command here, !python-m pip install gender guesser. Pip is the Python something Python install Python, I don't know. but it installs the little libraries, the extra libraries. So what this is doing is it is installing it not on your computer, it is installing it on the fake computer that Google has provided you in Colab. So that fake computer already has Pandas, which is why we didn't have to do that for Pandas, but Gender Guesser it does not have. So you have to press play here to install the Gender Guesser. Okay? Next, we import the Gender Guesser. Much like we import Pandas, we do the same thing for this thing called Gender Guesser. And then we create a gender detector that we call detector. So we have to press play here. If you don't press play on these, things will break. This isn't like the first module where you could just press play on some of them. Here you have to press play on everything. Next, so let's have a look at a random sample of 15 authors and feed all 15 names into the gender detector. So I create a sample of 15 here. It's a series based on the unique authors variable, that is the list of unique authors. And I sample 15 of them. And I picked a random state of 15 just so that it's always the same 15 people. And is it? Nope. This is different than when I was doing this earlier. So, are there problems that immediately show up regarding the gender guesser? We haven't even guessed genders yet. We are just looking at the data to see if the gender guesser will work. What are immediate problems that show up?
You don't have the first names for everyone.
Yes, we don't have first names for everybody. Like, if someone says, oh yeah, that person over there, their last name is Heath, that doesn't tell me anything about their gender. There are languages where you can guess the gender based on the person's last name. English is not one of them. Yes?
What's the number on the left?
Good question. That's the index value. So this is the plus, -1, the 6,233rd unique author is J.B. Heath.
Oh, okay. Their position on the list.
Yeah, their position on the list. It's plus minus.
Okay.
Like that's the simpler. The also, who's Gregory? Like I mean I don't know. Like is economics? Do you have mononyms? Mononymic superstars who just go by Gregory? Was there a question? Wei, you were pointing.
No, I was just wondering. Like, I guess we know it's random, but in a research environment where we're trying to be able to replicate somebody else's work, we'll never get the same set of 15.
That's so. Yes, so there's a couple things going on here. The set doesn't matter because we're just doing it. This is still exploratory, and we aren't going to be doing a sample. We're going to be doing everything. So in that sense, that doesn't matter. Typically, putting in random state feeds the same random seed every time. So at least here, when I do sample again, if I pass in the random state of 15 again, I will get J.B. Heath, all these other people again and again and again. But yes, correct, the sample is not the same. If I were sampling data and I were using that in a research environment, I would save the sample explicitly as a file, and that file would be, and I would like say this is the sample, precisely because of that, so that someone who is doing that work in the future and doesn't want to resample the data, they can just use the sample that I already provided. Yeah?
I have an extra question.
Yes, what?
Is this not like the historical data for many, many years?
This is 1900 to 2017.
So that's like a pretty long time.
Yeah.
And if you subset to a very only time, probably you only have male authors.
We are going to get to that.
And another thing is the repetitive names. Like the same name, but different people.
Yes. So we make no effort to if there are two J.B. Heaths, one who died in 1910 and one who was born in 1970, this is not sensitive to that at all. That person those two different people both appear as J.B. Heath in the data set, and that's it. That's maybe not a great example. Let's guess that David Shapiro is a male. So if there's a David Shapiro who died in 1910 and another one who was born in 1970 and started publishing in JPE in 2010, then those two David Shapiros show up as, are not distinguished as different people, and they are not distinguished as two different people as authors. So if there are two people named David L. Shapiro, that shows up as one male author. So the idea is that these are edge casey type things, and we're looking at broader trends. However, what's fun, well, you'll see why this is a little bit more important as I go on. So let's feed each name into the gender detector. So I do for name in sample of 15. So I have this group of 15 authors. For name in this group of 15, print name is coded as detector get gender name. And everybody is unknown. So, well, that doesn't help. So why is it unknown? I mean, the answer is very simple. If we look at the directions, we see that it says get gender Bob, not get gender Bob Shapiro. Wait, was that O.J. Simpson's lawyer? Robert Shapiro, I think so.
It was just
One of his,
Kardashian.
yeah, there was Kardashian, but I think there was a Shapiro also who may have been Bob Shapiro. I'm going to cut all this. It says, J.B. Heath is coded as unknown, David L. Shapiro is coded as unknown. So they say Bob, so we need to extract first names and only test on first names. We've already noticed that that's a problem because J period is not a first name. So let's see what we can do. The way you do this is you leverage a couple little helpful thingies in Python. A string has this split method, so string split. What the split method does is whatever you pass as the parameter into split, it uses that to break the string up into a list. So if I feed Charles S. Asher, which was in the list that I had when I was putting this together last night, but is no longer in this list, if Charles S. Asher, if I split it based on spaces, it becomes a list where the first value is Charles, the second value is S period, and the third value is Asher. So if I take the 0th element of that, it's Charles. So if I press play, I get Charles. So what I do is I take the string, I break it up into a list, and then I take the first value of the list. Of course, with J.B. Heath, or whatever that person's name is, it's just going to be J period. And so if we do this here, we'll see what happens. J.B. Heath is coded as unknown, because who knows? Oded Galor is coded as male. Sure. David Shapiro coded as male. Okay. But we have unknowns and males here. Now, there was Maria Cristina. It says unknown. Pretty sure that's probably a woman's name, but it doesn't know. So it doesn't know everything. Yes?
The previous code you ran for the Charles Asher example,
Yes.
is that for just a specific name? So how does that apply to the whole table?
I'll show you. So it says for name in sample of 15. So go through all 15 names. Then first name is equal to name dot split by spaces and then the 0th value. So it's going through all 15 names and doing it for every single one to get that first name. And that calls that first name, and then it feeds that first name into the gender detector.
So the previous one is just like a one-off example.
Yeah, just to show how
it's
split
not-
works. Yeah. So it's not great, it's not terrible. There's a lot of unknowns here, but again, Maria Cristina, okay, but H.P. Jenkins, no idea. So now, however, with this proof of concept, let's do it to everybody. So what we do is we take the list of unique authors and we create a new data frame out of it, and we'll sample 15 people from there. So it's the same 15 people. Well, that's a little bit convenient. So now what earlier we had a list, and now we have a data frame. So I just created a 1-column data frame out of that list. another word for that is a series, but this is technically a data frame. Now, and I call that data frame namesDF. So you have to press play here because we're going to use namesDF a bunch. Then I do namesDF equals first name, and then I apply that split command to every value of full name on the data frame. And then if I press play on that, we see now that we have 2 columns. So I created a second column called namesDF first name, and the value for that, feed in the value that is the 0th value of the full name when I split it, so the first name. But as you can see, sometimes that's J, sometimes that's H. So this is a way of iterating, and now this has done this for for all 10,000 names, or however many thousand names it is. It's about 10,000. So they all now have 2 columns, full name and first name. And first name will be something like J period. One of the first names is suggested, because I saw one of the authors was suggested by David Galenson. So that's not, David Galenson's a person, but suggested is not a person. So that was the first name. That came in as unknown. And then I'll create a new column called gender, where I take the first name and apply detector get gender to the first name and save that in as gender. So now when I press play, now the data frame has 3 columns: full name, first name, and gender. Yes?
Why does it say lambda over there? What does that mean?
I think I explained right here. So earlier when I used the apply function in the last module and earlier in this module, I defined a function explicitly and then ran that function inside the parentheses of apply. Python lets you skip that step and just define the function inside the parentheses. That's called a lambda function. I think you're not supposed to use them in Python. It's like not idiomatic Python to use them. It's much more idiomatic to define a function. In something like JavaScript, which is like JavaScript is much more familiar to me, you use the equivalent, a lambda function is an anonymous function. It's just a function that doesn't have a name. You use anonymous functions constantly. You don't even notice it. So, but in Python, I think it's considered to be a little bit of bad form. But I show this one line here is the exact same thing as these 3 lines. It's the exact same thing, except here I just describe the function on the fly, and here I go through the effort of defining the function. If your function is just one line, like feed the name into the gender detector, the lambda is fine. In other ones, if you're doing a bunch of if-thens or something like that, then you can't do that in one line with the lambda function. You might as well define your own function. So that's what the lambda function does. OK, so here's where things start getting really shitty. So these are the value counts for gender in JPE. So as we see, it picked of the 11,000 or so names, 7,000 were men, 2,800 were unknown, and 658 were female. Then there were 153 out of 10,000 that it said are most likely male, but they're not sure. 76 were mostly female, and 36 were androgynous. They couldn't tell at all. Like, I can't remember what an example of that is, but you can probably think of names that don't mark gender clearly one way, or famously mark gender both ways, as male or female. This number was much lower than I expected, the 658, I will be honest. And what is particularly notable here is if you take all of the non-male answers and add them all up, it's still not even half of the male authors. So even if all of these unknowns and mostly males and everything broke towards female, it would still be a 2-to-1 difference in authorship, which these don't break that way because let's look at the unknowns. So the unknowns include 259 instances of J period and then et cetera, and then a whole bunch of like 1 or 2 time appearances. Every time I run this, I think so every time I run this on different instances of Colab, the order of these is different, but so it has been my experience that the tail tends to be non-Western names, or extremely obscure names like Arcadius. I mean, Arcadius is probably a guy.
I have an Elmis.
Oh, so you all have different ones?
Yeah.
Oh, excellent. Oh, great. I was worried it would be just me. What's that?
Kevin. I have a Kevin.
Kevin?
Yeah.
Yeah, I mean, I don't know. This software is not perfect. And these are things that you have to take into consideration. But again, we're looking at unknowns here. If we changed it to names, DF, gender, let's change it to female, these are more clearly female names or women names. And okay, so of the 26, so there are 823 distinct first names. Some are legit first names, some are abbreviations. And the guessers sometimes just didn't guess, because it just can't tell. I skipped this, but I looked at the first letter of all of the first names. And in addition to all 26 letters of the English alphabet, there were also a few extended letters, like with accents on them. But then also, the first letter of their name was double quotes. Another person, the first letter of their name, or a couple people, the first letter of their name was the less than sign. So it's not bad data, it's encoding stuff that we don't know how to encode. If we scroll all the way back up here, we see that it says like Edward Leclerc suffix junior. So that time when it began with the less than sign, it may have been something like, I don't know, father something or other, so it had FR in the beginning, who knows. But the point is that this is a very blunt instrument that it does extremely coarse work that isn't particularly fine-tuned. If JPE had 50-50 men and women authors, and you were trying to make the case that maybe they're like a little bit biased against women because it's actually not 50-50, it's more like 52-48, then you would want to be more detailed with this sort of thing. When the answer is the gender thingy says 7,000 men against 658 women, I don't think that that's blunt enough of a difference that the little edge cases where, why did it not think that Kevin was a male name? It doesn't matter. These numbers are so far apart that these kinds of little edge cases doesn't matter. But this is, this has nothing to do with Python. This is about understanding your data set. Okay, so these are the women counts. Okay. So now we have to match our name to gender lookup table to the original list of authors, original list of articles. So this is a multi-step process, and you have to press play for all these things. So what we're going to do is we're going to create 6 new columns for the original DF data frame. So we're going back to the back to the articles. We've created this new data frame, names DF, that has full name, first name, gender, those 3 columns. And we're going to press pause on that for a second. And now we're going back to the original data frame where we added author count. That was the last column that we added, or the only column that we added. And now we're going to add 6 more columns to account for the 6 different kinds of genders that the gender guesser will give. Male, female, mostly female, Andy, or unknown. So the way we do this is a little bit clever, is we create a list, or I created a list here called male count, female count, like this. And then I iterate over that list, and for each of those values, I create a new column in the data frame, DF, gender counter column, and then I set it equal to 0. which is a very funny thing that Pandas lets you do. Pandas lets you set all of the values of a column equal to 0 just by doing df column name equals 0. You don't have to do like you don't have to iterate. You just do df column name equals 0. So if I do that, if I press play here, and you should do this too, press play, and then if you scroll all the way over, you get your author count, which is what we did in the last session. And then you get male count, female count. You get all these different counts, and they're all 0. The reason we are doing that is because in the next step, here's where things get tricky. We're going to iterate over each row in df, so each article. Then what we do there is we pull out all of the values of these 6 gender counters. They will all be 0 at the beginning, but they won't always be 0. Then we iterate over all of the authors in the creator field. And then we match the name in the creator field, the author's name in the creator field, with names df. And we get the gender from names df. And then we, based on the gender of that author, we increment either male counter, female counter, mostly male counter, we increment those counters by 1. So that if an article has 4 authors, we have an author count of 4, and then we'll end up by the end of this with an author count of 4, and if it's 2 male, 2 female, then it'll have the male counter will be 2 for that article, and the female counter will be 2 for that article. So this is I can't spend a ton of time on this, but this is why it's important to have a good grasp of how these loops work and this sort of stuff, because then you can really start to see the structure. So I describe it here, like, the description I put up here on screen is actually what the code ends up looking like. Like, we see that we have a loop, iterate over every row in df, then we have another loop, iterate over the list of authors, match the name, increment the thing, and then return the gender counters dictionary. And that's exactly what we do here. We create a dictionary called gender counters. It's empty. Then we fill it in with all of the gender counter names, again, male counter, female counter, etc. And then we iterate over so we're already iterating over every row. That's implicit in what we're doing here. You'll see what I mean by that in a second. So this for author in row creator is iterating over the list of authors. This function gets a row and it iterates over the list of authors. Match the name in df names using the loc method. So that's names df loc, names df full name equals author. And then read the gender column and give the first value. Because what this does, names df loc, names df full name equals author, is it gives you a list, it gives you a new data frame of all of the values that match that author name. We know that there's only one, but there's no way to say there's only one. So we assume that it's a data frame that's n tall, and we just ask for the first one. So and the other assumption is that there will always be at least one. We know there's at least one because these two data sets are tightly connected because one is derivative of the other. But if someone sent you a spreadsheet that was like, yeah, here are all the authors in JPE, and someone else sent you a spreadsheet and said, here's a list of all the articles in JPE, and one person got them from whoever U of C published. One of them got them from the U of C, and another one got them from JSTOR. Who knows if the names are the same? But here, since we derived the list of authors from the list of articles, we know that they are the same. So we can be a little bit more, we can trust the data more. Then we have to do a little bit of string manipulation to change the name, and then at the end we increment the gender counter. So this is a function that we then feed into apply. So df gender counter columns is a list of 6 columns. This is all very tricky. I explain it in great detail here. And this is the first big command that we run because we have to iterate over 10,000 articles, and for each article we have to iterate over 10,000 authors. So that's 10,000 squared operations minimum. So it takes like 30 seconds, which is the biggest command we've run so far. We haven't run any command so far that takes 30 seconds. So all this is, now it'll take 30 seconds. So what this is doing is it sets these 6 columns by applying the command to increment each of the different gender counters based on the gender of each author, and then it returns those 6 columns again. This is tricky. I had to test this a bunch to get it to work, but the way it works is a little bit straightforward. It's a little bit elegant, maybe even. And the important thing is it does what we want it to do. And see, it took 31 seconds. And now we can do something like sort the values by author count and see if they make sense. So author count is 16, male count is 8. Where are the other 8? Oh, surprise, they're an unknown. Author count is 13. Oh, all 13 are male. Author count is 10, male count is 5. Where are the others? Oh, unknown. What a surprise. Et cetera, et cetera. So we can sort of see that this makes sense, right? It looks like it worked. I mean, I can guarantee that it worked, but it looks like it worked from looking at this. Yes?
In the previous command, it says axis is equal to 1. What does the axis mean?
Great. So when you run many commands in Pandas, it can run column-wise or row-wise. I think that there's something broken with my thinking in that I only ever want to run row-wise operations. I never want to run column-wise operations. But Pandas as a default runs column-wise operations, which means that axis equals 0.
Okay.
So by doing axis equals 1, that means do a row-wise operation, which means you go row by row by row, as opposed to column by column by column by column. Again, my head doesn't, my background in databases or who knows, but I always think in terms of row-wise operations, not column-wise operations. But that's what that is. Something like apply, there are a bunch of methods that can go either along the x-axis or along the y-axis, and that's, or the row or column axis, and that's how you set it. Axis equals 1 means up and down. And result type expand is how I'm able to change 6 columns at once. I explained it all up in here. Okay, so now we have the author count of every article in JPE, and we know how many of each gender contributed to every article in JPE. So now we can kind of do a little bit of analysis. So first, let's just look back at the value counts, but look at them in terms of percentages. I just want to show this math, like somehow I take a series and divide it by a single number and end up with 6 percentages. That's a little bit weird math because it looks like I'm just doing one thing divided by one thing and get 6 answers, but it's because the first one thing is actually 6 things. So this is the kind of fun math that you can do with Pandas. So yeah, so we see 65% are male, 26% are unknown, 6% are female, et cetera, smaller and smaller, smaller. So identifiably male authors, and again, it's not perfect because even of that 65%, I'm sure there are 1 or 2 that are just misgendered, but 65% of the total, et cetera, et cetera. So I was trying to figure this thing out and be like, well, obviously JPE has made big efforts to publish more female authors recently, right? Because economics maybe has a long history of only having male economists, and now, if I were to plot the number of female authors per year, it would obviously be like low, 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 and then like parity. That's a great hypothesis. Let's test it. JPE by year is grouped by publication year. So just like in the previous module, we grouped things by publication year so we could see how many what was the average author count over the years to see if there was a tendency towards more authors or fewer authors. And what was the average word count to see if there was a tendency towards longer or shorter articles. Now we're going to do the same thing to see what is the tendency in terms of female count by year. And like kind of noise. But it's definitely not what I said in the hypothesis, which is women didn't used to get published in JPE and then started getting published. This is not what this chart shows. There are problems with this chart. This is a raw number, a raw count of how many women authors there were in every year of JPE. Why? Can you think of what the problem is with making conclusions based on that?
Probably need to percentage years, male numbers.
Right. So the number of different authors every year is different because the number of articles is different every year and varies widely, in fact. So there's no normalization. So if, the most women ever published in JP, well, let me rephrase that. The most times a woman author was published in JP, because again, it could have been the same woman 10 times, was around 1939 or so, where there were 24-ish women authors in JPE in 1940. I think that this was the busiest period in JPE's history when it had the most articles. So, but we saw that the number of articles, I don't remember. But this is not normalized. So like Wei said, we need to be a little bit careful about these kinds of time-based things because we have to make sure that we're comparing like things to like things. If the number of articles it goes down over time, but the number of women authors remains the same, then clearly that means that women authors make up a larger proportion of the authors. And then, I'm done. This is the last thing. So it worked out right on time. I made this chart of total authors. So we can see that the number of total authors declines over time, rather remarkably. And we see that the number of male authors per year declines rather remarkably, like unsurprisingly looks almost exactly the same because such a huge chunk of the authors are male. But the fact that it declines so similarly even when technically more women authors are supposed to be getting published indicates that women authors aren't really like playing a huge role in that change. They're playing a little bit of a role because the number of women authors has been around 5 a year since the 70s, when the number of authors has fallen since 1970, has fallen from about 150 to a low of 70. So, even at its lowest, when you had 70 authors published in a year in JPE, you could expect a maximum of 10 women authors. So, already this sets up all kinds of opportunities for research questions. Like, for example, what is this peak about? This peak was in the late 30s. Was there a similar peak in the late 30s? Yes, but not compared to this peak in 1950. What was this big drop? Was this war related? Who knows? But these are like questions. What happened? What's that?
World War II.
Yeah, but why just 1 year? Or it looks like 1 year, yeah, it's just 1 year. Why was there this growth in number of authors and then poof, it fell apart? I mean, again, World War I, sure, but why then this explosion back to normal in around 1930? You know, these are the history of the field, you know, how to sort of account for this. And then unknown, we also see that unknown follows a similar, because one of the hypotheses I had, I've noticed that a lot of, so my field is English, and in literature journals, you don't obfuscate first names. Like in the bibliographies and stuff, it's always the full name of the author. Whereas I know that like in geography articles and social sciences articles, you'll often just have the first initial and then the last name. I thought maybe this was a sort of thing that came about in the 90s or something to sort of like obfuscate the gender of the authors to encourage less bias or something. So maybe that's why there's a rise in unknown authors in around 2000. I don't know. This was just like me speculating. Another thing is we know that unknown signals a lot of non-Western names. So could it have been the case that JPE started publishing more non-Western authors so they get coded as unknown? Maybe. But then why did it collapse? Like why was there like whoop, lots of unknown people for about 5 or 6 years and then it fell again? I have no idea. These are questions for you to ask, I guess. But that's it. And we are done on time at 3:30. So I think, right? Yeah, 3:30. So this has been a ton. Hopefully it has not dissuaded you from learning more about this kind of stuff. I know I moved like super quickly and you know, I documented stuff rather in detail that I just moved over really quickly. As always, if you write to data@library, you will reach me or Wei, who is my fellow colleague in research data services. So again, as soon as you start using a spreadsheet in your research, you should consider sending us an email and we can help you with that spreadsheet. Because one version of this is just, everything we did here we could sort of do with Excel. It just wouldn't, it would probably take way longer and be less satisfying, I think, in the end. But yeah, I'm sorry that JPE publishes so few women. I wonder how it compares to other top economics journals. But this is, you know, if you want to do a sociology of the field, this is a good place to start, to be like, this is weird. This is weird that it hasn't gotten noticeably better. This is weird that for some reason there are a bunch of unknown gender people getting published in JPE, but only in the 2010s. You know, so what to make of that is your dissertation topics, I guess, or your capstone project topics. All right. I think that we set aside the last part of this, like the last half hour, to sort of talk about any kind of general questions you have. I completely punted on talking about text analysis specifically. There are a couple hundred words here to guide you in that direction. But if you have any other questions that are more general or whatever, we can start with them. But before that happens, I'm going to stop the recording.